show that it is a parallelogram. So let's focus on finding H first. What do we know about the sides of a parallelogram, the opposite sides? Gary? Yeah, opposite sides are congruent. So to find H, what is he going to set 16 minus H equal to? Equal to? So again, opposite sides of a parallelogram. Opposite sides in a parallelogram are congruent. And when you're trying to find sides, the only thing you can do is set sides equal to each other. So you just have to figure out which one of these you'd set 16 minus H equal to. And then solve. How are we going to solve for H? We get negative 8 is equal to negative 9. Tell me what's in front of that H. Negative 1. How are you going to get rid of that negative 1? Gary? Very good. We're going to divide by negative 1. So H ends up equaling what? 9. We don't have to plug it back in. The directions don't tell us to find the distance. We just need to find the variable. Now let's take a look at G. What is G? Is that a side or is that an angle? Angle. How do we know it's an angle? It's inside, and what's kind of written with it? Angle. Yeah, it's written with a degree symbol. That's going to indicate to you whether or not you have a side or an angle. Well, thinking about parallelograms, what do we know about the angles of a parallelogram? Gary? You are correct. Alternate interior angles are congruent. We don't have a diagonal drawn. You're on the right track, so. Chloe? Yeah, you can add the angles next to each other. You can add them and set them equal to 180. How else can we solve this? See? Yeah, you can also, we know opposite angles in a parallelogram are congruent. So we can set the opposite angles equal to each other, or add the two angles next to each other, set them equal to 180. I'm going to set these equal to each other because it's less than. Either way is acceptable. Either way gives you the correct answer. Okay, how are we going to solve? Here's subtract 4. So D is equal to what? 1. We are done. Questions over there? If we look at 2, what's X sitting on? Is it an angle? A side? On the right track with a side. What part is this sitting on? Side. On a side. What is it? A diagonal. Yeah, 5x is sitting on a diagonal, along with 4x plus 4. What do we know about these two pieces of the diagonal? They equal each other. They don't equal 180.
So which one? They don't equal 180, but it's still a line.
Because we're talking. You're right. Straight lines are 180 degrees. We're not talking about the angle. We're not talking about the angle of the line. We're talking about the distance of the segments. So you can never, ever, 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 do not ever do this. Add segments and set them equal to 180.
Someone's going to try to do it. We're telling you right now, they're never going to equal 180.
Don't do it. Ever. Only do that with angles. So, what is the only thing we can do with segments or sides or diagonals? Set them equal to each other. That's the only thing we can do. We're going to say 5x is equal to 4x plus 4. Because what do the diagonals of a parallelogram do? Bisect each other. So they're cutting each other in half. So these pieces are going to be the same. You just set them equal to each other.
So if it was one line, it would be 180.
If we were talking about an angle, we're talking about segments. Segments don't equal 180. Angles equal 180.
Okay.
So when we solve, move the 4x over. Yeah, x is equal to 4. Done. That easy. What are we going to do to find y? Semi-equal, we're going to do the exact same thing. Because again, the diagonals bisect each other. So these two pieces are the same. So we're just going to say 3y is equal to y plus 8. And then solve. How are we going to solve? Move a little y over. 3y minus y is 2y. How are we going to get y by itself? Divide both sides by 2. Y is equal to what? 4. And now we're done. Question? Again, if you're given segments or sides or diagonals, the only thing you can do is set them equal to each other. That is it. Can never add sides, segments, diagonals, can never add them to 180. So don't do it. Okay? Questions over there?
All right. So, go to this. Now we're going to the next section here. We have quadrilateral QRST. It's a rectangle. Find x. You have to know about various properties of different shapes. What is the one thing that makes a rectangle a rectangle? Definitions.
All sides are 90 degrees.
Not sides, but all angles are 90 degrees. Very good. That is what it means to be a rectangle. I'm going to go ahead and draw that in there. So I know all these are 90 degrees. Good. Now that I have that labeled in there, it might help you visually understand what's going on a little bit here. So, what do I know about these two angles over there? These two pieces right there, what do I know about those two pieces? They do equal 90 together. A common question, or a common thing people say is they're equal to one another. Because, again, guys, in this unit, this test, there's only 3 ways to set up and solve. The first thing, set them equal to one another. That doesn't work, add them up, set it equal to 90. That doesn't work, add them up, set it equal to 180. That's the whole thing here. But we know it's a rectangle. We need these two angles together do equal 90 degrees. They are not necessarily equal. There is another shape where they are the same, but it is not in rectangles. So yes, I will add these up. 4x plus 5 plus 9x plus 20 does equal 90. Now, again, it looks like it's drawn out, very complicated. It is not, because we know the next step will always be combining these like terms. So, 4x and 9x give me a 13x is correct. 5 and 20 gives me a 25. Still equals 90. That is what we want. Nice two-step equation. Bear from. Let's start solving. What am I moving first? 25. Correct. Instead of doing add 25, I will subtract 25. Do to one side, do the other. You guys are on a roll right now. And I know 13x is equal to, you said it, 65. One last step involved to solve. Divide by 13. There you go. 65. Fine, what are you gonna do up there? Is 5. Good. So, are we done? Are you sure?
Yeah.
I hear no. It says 5x. Did I find x? Then we are done. We don't have to go any further. We know we plug it back in. You can always check yourself plugging it back in. But we got it right now. Found x. There it is. Moving on. Now this one, 4 through 7. It says classify the quadrilateral. Explain your reasoning, then find the value of x and y. All right. So let's see what we got here for number 4. The following figure is a parallelogram. Fantastic. Angle D is a right angle. BD is 4x plus 3. AC is 2x plus 35. I have a picture. I've got information. What should I do with that picture and that information? Plug it in, label it, whatever you want to think about it. D is a right angle. Go ahead and draw that in there. There's D. I know that BD, that whole segment, is 4x plus 3. And I know the other segment is 2x plus 35. Okay, so first thing we have to classify what sort of shape this is and why, based on the information I have given. Gary, what sort of shape is this? It is a rectangle. Why is it a rectangle?
That's all sides are 90.
That side's the... Yes, because it's a rectangle and you would say 4 right angles. Because, again, the rule is you have 1 right angle, you have 4 right angles. Because we know in a parallelogram, opposite sides are congruent, or opposite angles are congruent, excuse me. So that's 90. This is also 90. Angles side by side are supplementary, so those are 90. And that is a rectangle. Yes, it is. All right. Good. Well, we have nothing about the angles. Last time we had something about those angles over there. This is dealing with something else. What do we call those lines that go across the figure like that? You're right. They do bisect. What are those actual lines called, though? Diagonals. Diagonals do what to one another? They do bisect. There's one more special thing about rectangles, though, involving the diagonals. What do we know in rectangles about the actual lengths of those diagonals? They are equal, they're the same. So if I know I have that red one and that blue one up there, what equation could I set up with those if I know they are the same? Yes, Gary, question. You're right, set them equal.
Why did it say find the value of x and y?
Because it goes for, there's other ones that have y on it. This one doesn't have a y, so once we find x, we're good. But the next couple have y's in them. All right, so we know that diagonals are congruent, so let's set them equal. So 4x plus 3 is equal to 2x plus 35. Let's go ahead and start solving a little bit. Try to get that bear problem. Minus 2x, be dead. So 4 minus 2, 2x, plus 3 is equal to 35. Back to that two-step for justice, yes? I like it. Be gone. 2x is equal to 35 minus 3 gives me this number with a 2 and a 3. Last step, divide. What is half of 32? What'd you say? 60. Good. Good. Next problem, right? We're done? You're right, but there's no y in this problem. So, we are done. We found x. I promise you there will be a y in the upcoming problems. Questions on those? In rectangles, diagonals are congruent. Set them equal.
Monday, can we have partners?
Partners?
Yeah, to go over this?
No. We still got the last one here. All right, number 5.
If we look at number 5, what type of parallelogram do we have? We have a square. How do we know we have a square?
All the sides are the same.
All the sides are the same. What else do we have? All the angles are what? 90 degrees. That's how you know you have a square. You have to have both. You have to have 4 congruent sides. And you have to have 4 right angles. You have to have both. Again, please make sure we are paying attention. We do have a test next week. You have to have both. Now, you can't just have 4 right angles, or you just can't have 4 congruent sides. You have to have both in order to be a square. Well, how are we going to find x? Was x a side or an angle? A side. That's the only thing we can do with sides. Set them equal. Does it make sense to take 3x and set it equal to 5y plus 1? Does that make sense to you? Can we solve for one variable in that problem, though? What's the only thing we can set 3x equal to?
5y.
Can we, though? Yeah, 5x minus 4, because all 4 sides are the same. So yes, we're so used to setting the opposite ones equal, but that doesn't work out in this case. But because it's a square, any side are the same. So we can do 3x is equal to 5x minus 1. So really, when you have sides, just find the side that has the same variable, set them equal to each other. When we're solving, I know we're used to moving the little x over first, but in this case we have to move the big X. We get negative 2x is equal to negative 4. How are we going to get x by itself? Divide. So x is equal to 2. Found x. What are we going to do to find y? 7 equal to the exact same thing. You just take the two sides that have y, set them equal to each other. We're going to say 5y plus what is equal to 2y plus 4. And solve. How are we going to solve this one? What do we want to move first? Move the little y first. We're going to move to y. All the way. With 3y plus 1 equals 4. Now how are we going to solve it? Times 1, move the 1 over. The 3y is equal to 3. And then how are we going to get y by itself? 5. 1 by 3 divided by 3. Y is equal to 6. And the only thing you can do with sides is set them equal to each other. That is it. You just find the side that has the same variable, set them equal to, and solve. Questions over there? What kind of parallelogram do we have in 6? Rhombus. Okay, why do we know it's a rhombus? 4 equal sides. So why isn't it a square? Squares have 4 equal sides. Very good. It doesn't have right angles. This guy right here is saying it's 127 degrees. That's not a right angle. So the only thing it can be is a rhombus. Or congruent sides. I'm going to find y first. How are you going to find y? Then, is it a side or an angle? Side. It's the only thing we can do with sides. Equal them to each other. So here's a side with a y. Here's a side with a y. Set them equal to each other. Only thing you can do. And then solve. Move over the little y. To get 3y minus 5 equals 7. Your basic bear problem. How are we going to get y by itself? Where do we want to move first? How are you going to move the 5? And then last step to finding y, what do we have to do with 3? Very good. So y ends up equaling what? 4. Okay? When you have sides, that equals solve. If we try to find x, what is x? Is it a side or an angle? An angle. How do we know it's an angle? There's the degree symbol. Right there. Very well. How can we find x if we know it's an angle? Close. On the right track. Add it and set it equal to 180. Yeah. Because they're next to each other. So then we know those angles add to 180. If they were across from each other, then we know they're equal. So next to, add a 180, across, 70. And so. Combine your like terms. When we combine our like terms, what do we get? What do we get when we combine like with negative 1 plus 127? That's it. 1.6. Yeah, you can continue to get x by itself. Move over the 126. What's 180 minus 126? 4. And then last step, what do we have to do to get x by itself? So x equals what? 7. Very good. And we're done. Look at them. Again, sides, the only thing you can do is set them equal to each other. Angles are equal each other, add to 90 or add to 180.
Let's look at number 7. This guy. So looking at 7, we got to first classify what sort of shape is it. So number 7, what sort of shape is 7? Square? Clear square?
We can't tell it's a rectangle because it doesn't say that.
I agree. You guys are, a lot of you guys are saying the right stuff here. It looks like a square. Looks like a square, right? But based on the information we have here, we do not have enough information. It very well could be, but based on what we have, we cannot say that. So, based on what we have, it has to be a rectangle, because the rectangle listed has 4 right angles. I know nothing about the size. We could prove it down the road and show that it is, but as what we have right now, we don't have enough. So this is a rectangle once again. It's a rectangle because, again, we have 4 right, feet, 4 right angles. 4 right angles. Okay. Well, let's go ahead and solve. Let's solve for the y first. I think that's easiest. Is y a segment or an angle? It's a segment. What do we do with segments in this whole unit? Set them equal to one another. Again, these are sitting on diagonals, and we already know what do diagonals do to one another inside parallelograms? Well, they equal each other. They bisect. So that means they will be equal. So we are going to do that. So I'm going to say that 2y is equal to 10. And yes, I realize most of you can look at this and already understand what y is going to be. But some people, it still helps to put this in an equation so you know what's going on. So my next step will be divide by 2, divide by 2. So y will equal 5. Y does equal 5. Because 2 times 5 is 10. Nice. So we're done with the y's. Pretty quick and easy. Now let's go on to the x's. These are angles. So we got to know some things about angles and parallelograms. So who's got an idea how to solve for the x's? Set them equal? How can I set them equal? Yes? Set them equal to 90? Great guess. Or 180. That'd be a thing. But I like this. If I knew they were the same spot, if this one was up there and that was right there, I would definitely set them to 90.
Oh, no.
Because they're sitting in that corner. But they're not sitting on that. There's something with that diagonal. That diagonal is key. And we already kind of hit on it right here. What do we call these types of angles? Huh? Alternate interior angles. Very good. Because remember, ultimately, this is a parallelogram. That's parallel to this. Those are sitting on opposite sides of the line and inside. Alternate interior angles. And what do we know about those values? They are equal. Alternate interior angles are congruent. So I can say that angle is equal to 3x plus 18. Solve. Minus 3x. Gone. 5x minus 3x. I already kind of hit it for you guys. You're welcome. Equals 18. Last step, divide by 2, divide by 2. X is equal to 9. X is 9. Yes, question. The reason why I would is this is a square. Because these will both be equal to 45, right? No, that's not right.
I don't know.
Well, if we plug, that's a 45. But I'm saying once we do it, that's why she lucked out of this. You cannot always do that. It lucked out for this because this is a square.
Wait, it's not.
We didn't
So
know
we
it.
did all this wrong.
No, this is right. But I'm saying we proved it's a square. Huh? Because based on the information I had, it is a rectangle. All this work shows that it really is a square. So that's why when you said those two together, set them equal to 90. If this wasn't really a square, it'd be very, very close to it, those wouldn't be equal. But based on the information I have here, since they have alternate interior angles, you have to set them equal to each other. It just happened to be that this really is a square.
It's not a
It's
square.
not always going to work out the way you think. It does look like a square, and I agree. And it is a square, but we didn't know it based on information. Gary, question? Okay, well, we'll get there. Let's get there. We'll get there in a second here. All right, let's look at number 8. So we're getting out of those rectangles, all this stuff. We are now moving into trapezoids. The nice thing is there's only 2 trapezoids we work with. A regular trapezoid and this other trapezoid. What is it? I think you said it. Trapezoid and this other trapezoid? Isosceles. It's an isosceles trapezoid. It is very similar to an isosceles triangle. And what do you know about isosceles triangles? 2 sides are the same. So these 2 sides are the same. We call those legs. And we know something else about those angles in isosceles trapezoids. What do we know of those angles? If the legs are the same, what do you know about the angles? The base angles are the same. I'm going to mark it on this picture. I know that here's my bases. Their angles will be congruent. So that's congruent to that.
Okay, how is it the base? Because the bottom is supposed to be the base.
There's 2 bases. There's a top base and a bottom base. Because there's a top and bottom. So depending on how you look at it, could be the base that way, could be the base that way. So not only are those top bases congruent, we also know these bottom ones are congruent. Because isosceles triangles, the base angles are congruent, and also isosceles trapezoids, the base angles are congruent. So x is really easy to figure out. So what is the measure of x? 50. Because they're base angles, they are the same. That is 50 degrees. Good. Y is easy as well. Just got to think about it a little bit. What's the measure of y going to be? Or so tell me how we can get that. Let's see, listen, we got the same people over and over again. Good. Yes, Katie in the back. 130. How did you get that 130 number? Just shout out numbers. What say guy here? What equals 180? X and Y. Angles that are side by side are supplementary. Again, if you look at these parallel lines, these are what we call same side interior. So yes, they do equal that. Notice this is different from parallelogram compared to trapezoid. Not all angles side by side are supplementary, because 50 plus 50 is not 180. But it's the ones that sit on the bases. The base angles are supplementary to one another. So if I know they add up to 180, I can do 180 minus the angle I know of 50, and that will give me what my y value is. So just like you said, y is going to be 130. Do the same. Another thing too is, this is another helpful way, of angles that are across one another in a trapezoid, those are supplementary. Because if I do 150 plus 130, that would give me 180. So another way of looking at it, however you want to think about it. Okay. Number 9. Here comes number 9 at you.
So look at number 9 again. We have a trapezoid, and we have to find that middle line. What do we call that middle line?
Median.
It's a median or a mid-segment. Median or a mid-segment. Either one is correct. So whenever you have a median or mid-segment, and we know it's one of those because it's cutting these sides in half, what do we have to do with the top and the bottom? Find that middle line. We did yesterday. Let's do the top and the bottom.
Oh, we did that. Add them together and subtract them.
Add them together. So we're going to do 10 plus 18, and then what do we have to do? Add together, divide by 2. And that will give you your that middle line, your mid-segment. Add top plus bottom, divide by 2. And it gives you that middle line. Well, what is 10 plus 18? 28. And 28 divided by 2? So that middle segment is 14. Top plus the bottom divided by 2. Like finding the average. Okay. For 10, it's that same kind of concept. We have a middle line, we have that mid-segment, we have that median. To find x, we use that same process. You add the top and the bottom. X just happens to be in the top. And divide by 2. Top plus the bottom divided by 2 equals that middle line. The setup is the same way. Whenever you have a trapezoid with a middle line, top plus the bottom divided by 2. Sometimes the x is going to be the middle line. Sometimes x is going to be the top or the bottom. Setup is the same way. Just how you get x is going to be different. How are we going to get x by itself? Get rid of that 2. We're going to multiply both sides by 2. Super tempting. We want to distribute that 2. Don't do it. The reason why we multiplied by 2 was to get rid of it. So they cancel. We're just left with what's in the top. 20 times 2 is 40. And then to get 17 by itself, subtract it, and x is equal to 20. Some of these little ones, it's easy to think, oh, 20 is 3 away from 17. 3 away from 20 would be, again, 23. You can think like that. Sometimes with these harder ones, it's easier to set up an equation. You can't really see it. Questions over there?
Moving on to the other shape. We have the old rhombus. The rhombi. So in rhombus, JKLM, measure of LMO is 30. OJ is 18. MK is 36 radical 3. By the following. Again, I've got information. I have a blank picture. I should plug it in, label it. Good idea. So, to the first one here. LMO is 30. LMO, 30 degrees. Very helpful there. OJ. OJ's right here, that little segment. That is 18. My other one, MK, is this whole segment. I'm going to write it over here to say that's 36 radical 3. Find the following bits of information. I need to find the measure of JOK. JOK is right there in the middle. What is something special I know about rhombuses or rhombi in their diagonals? What is special about how the diagonals are formed? They do make a 90-degree angle. So I know that there's a 90-degree angle. Anytime I have a rhombus, this should be one of the first things you draw in there. It's 4 right angles within that intersection there. So that might help you figure out what JOK is. Recognize it?
Yep.
JOK up here is going to be what measure? Recognize, volunteer, thank you. It's going to be what measure?
Wait, what's the question?
Oh.
JK.
JOK is what measure?
Where's the O? I don't see the O.
It's right there at the center.
Oh, JOK.
What is the measure of JOK? We just said it.
90.
It is 90 degrees because there's right angles within the middle. It's 90 degrees. It's listed there. So let's do the next one. LKO. Where's LKO at? Let's look. LKO. This angle right there. What is the measure of this angle?
90.
No.
Oh, no, it's not.
Let's
30.
measure this.
No.
No, we don't know.
I don't know.
Again, that's why we're going to have this.
45 plus split it in half.
We don't know. There is something, guys. It does split in half. Because when we have diagonals, they are angle bisectors. We also know in parallelograms, opposite sides are congruent. So if opposite sides are congruent, if this is 30, what's the other side have to be?
30.
30. This is also 30. Not only is that, I told you it's an angle bisector, so this is also 30. Therefore, this side is also 30. Lots there, because they are going to be the same. So this is 30 degrees. What about MJO? MJO. We're looking at this angle right here.
90.
It is
Just
not
kidding, no, it's
90. Not 90.
No, I'm just kidding. I'm just kidding.
Only 190 there.
Wouldn't you add 90 and 30 and it's actually 180 because apparently it wouldn't.
What do you say? 60. You're right. Exactly what Kadaja was saying here. She's saying, won't I add those together? Well, you can do that. That's fine.
30, 60, 90.
And it does make a triangle. More importantly, a right triangle. That measures 30. That measure 90 is 90. So that means the other one has to be 60.
30, 60, 90.
It is a 30, 60, 90 triangle. Very good. So those are the angles that we have in here. Now we're moving on to segments.
Oh,
So we're finding LJ.
Oh.
LJ is this whole diagonal right there. So what is that measure?
If it's split in half, then we just times by 2.
It is if it's split in half. Very good, because we know all diagonals bisect each other. So if that's 18, that means that side has to be 18. Or can I just say multiply that by 2? So what is 18 plus 18, or 18 times 2? It is 36. So LJ is 36. Now, there's actually a couple different ways to do this next one, but we're trying to find what LK is. People figure this out different ways. There's multiple ways to answer this.
Not possible.
It is possible. There's actually multiple ways to solve it. What I would say is this. Just like before we did this purple triangle, there's a triangle right there. I'm going to draw over here so you can visualize it a little bit better. I know that's 90 degrees. I know that's 30. I know this is 60, because opposite sides are congruent. And I know this is 18.
We gotta do trigonometry.
You could. I wouldn't do trig. I would do the special right triangle shortcut, because this is a 30, 60, 90 triangle.
Isn't it trigonometry?
It is trigonometry when I'm just trying to use the angles to find it. It is. But I can do a lot quicker than just using my special right triangles. And at 30, 60, 90, how do you go from a short leg to a hypotenuse? I do multiply. Small and big I multiply. What do I multiply by? 2. So 18 times 2 gives me a 36.
I thought you put it radical 2. I thought you put radical 2.
Radical 3 is the other side. Question?
If 18 is the shortest side, then does it, like it's supposed to be X.
This is X out here. The short leg's X.
Short X and multiply by 2.
Yep. So this side would be 18 radical 3. And the whole thing is 36, so really 2 of these is 36 radical 3. So your correct answer is 36. Someone else brought up the point that, you don't need to know this, but I'll show you, someone else found out earlier. I didn't even think of it this way, but if you think of these two triangles put side by side, this is a 60-degree angle, that's a 60-degree angle, 30 and 30 is a 60-degree angle, it's an equilateral triangle. All the sides are the same. You guys told me this one's 36, so those two are also 36. So either way you think about it, that's what you get.
Yeah.
Multiple ways to get these answers.
Okay, now we need a time.
Flip it over.
Okay.
We got, oh no, flip it over, my bad. I forgot about this little guy. So we have rhombus JKL. JKLM. We have Mo is 4. Let's label our pieces. Mo is 4. I know JL is 16. This whole thing is 16. Let's find these various pieces. These are just sides or segments. So what is low? What is the measure of right here?
J-Lo.
What is the measure of low?
8.
How did you get 8?
Because it's a bisected.
Their diagonals are bisected, so therefore that is 8. This is also 8, so low is 8. KO. How'd you get 4?
Coco.
Why did we get 4? It's a diagonal, so it's bisected again. But notice, this is not drawn to scale. Because obviously, this is 8, that's 4, 4 is bigger than 8, so you can't always assume. But that is 4. The last one is KL. It's over here.
We gotta do Pythagorean theorem.
You do, but we need a right triangle, or right angle to do that. But luckily, this is a rhombus, and we know rhombi always have right angles. So I'm going to draw that triangle over here so you can see what it looks like. And Kanaja is correct. I know the bottom one is 8. This side is 4. I do have to use Pythagorean theorem, because if I'm doing two sides, I have to find the other one. So I go to do, what's the one rule about Pythagorean theorem that always has to be true, though?
Hypotenuse has to be C.
The hypotenuse has to be C. So let's go through and solve that. I'm going to say 4 squared plus 8 squared is equal to C squared. 16 plus 64 is equal to C squared. 16 and 64 gives me a 80 is equal to C squared. How do you want to do a square? Square root. Now this one you can just give me the decimal. So you can just give me an approximate answer. When you do the square root of 80, you get approximately this answer being 8.9. Good for me.
We're done.
No, we're not. We have the last one. Yeah, that's gonna work out.
Go ahead and cross this one off.
Oh, yeah.
You don't know how to do it. Cross it. Don't do it. That's for next. We take a look at 13. Says they proved with the missing statements and reason to show. They gave us our given, what we're trying to prove, and we're trying to fill in the correct statement for line 3 and the correct reason for 3. That's it. We don't care about 4 or 5 or 6. Okay? Well, we know that this information or given information is going to go where it says given. We know that much. And PQ is congruent to QR. Well, what do we normally have if they didn't give it to us this time? We should probably draw the picture. So let's go ahead and draw the picture. They didn't give it to us, but we can draw one. Alright, it's a little kind of sloppy, but we have a P, Q, R, S. We're trying to prove that this parallelogram, not really drawn to scale, is a rhombus. They said PQ and QR are congruent. Okay, well, we're going to look here to figure out what our next statement is going to be. And I like to rule out the ones that don't make sense. Well, PQ is congruent to SR, PS congruent to QR. That makes sense. That could be a possibility. But what about these two? It has T in it. Is T written anywhere in that diagram? No. So that's definitely not going to be part of our answers. What do we know about a rhombus? What about all the sides? All the sides are the same. So would it make sense to talk about angles?
But you caught me 4.
No.
2 and 3.
So the first one makes the most sense. The two middle ones are talking about T. That bottom one's talking about angles. We only care about sides. So that's going to be our statement for number 3. Okay, so again, we said that this one would be the best statement for 3. The middle two did not make sense because it was talking about point T, and point T isn't even in the diagram. In the bottom one, it was talking about angles. In order to show that a rhombus, parallelogram is a rhombus, you're going to try to show that all 4 sides are the same. So that first one made the most sense. Now we have to figure out which one of these reasons matches up with that statement. Well, again, in our statement, we're talking about sides being congruent. We said that PQ is congruent to SR, and PS is congruent to QR. Okay. Well, this one makes sense. Does not make sense to use because it's talking about angles. So we're mentioning sides. This bottom one doesn't make sense because it's saying side. That's talking about congruent triangles. We're just talking about sides being congruent, not triangles being congruent. And this first one doesn't make sense because it's talking about diagonals. Well, those parts we marked were not diagonals, so that one doesn't make sense. So that leaves us with opposite sides of a parallelogram are congruent. And if you notice, you marked those opposite sides. You marked PQ, and then you marked SR. Those sides are opposite of each other. You marked PS, and then you marked QR. Those sides are opposite of each other. There you go. Again, make sure you cross out 14. Don't do 14. That's for next unit. Snuck its way in there. And then the back problems, those are problems from Unit 4, which you can go back and do on your own.